Hello and welcome to part 6 of the UBIK solution. In this video I want to start off by addressing a potential issue you might have, and it has to do with the UMAP file, which might be corrupt, or it seems like it's corrupt. And I was made aware of this by a user called Bambusbo, which contacted me on Discord. So we found out that it has to do with this LFS types of files. So you might have to download this client here from the link git-lfs.github.com. I'm going to put a link to this in the description so you can download it if you have this issue. If you're using source tree, I don't think you do have this problem, but if you're pulling this manually from the command line or something similar, you might have this issue. So go ahead and download that if you have that. Alright, so in this video here we're going to address the positioning of a what we will call a shoulder bone. And in the Parcher paper, Matthias Parcher, he refers to this as this bone in between your shoulders, your actual shoulders, as the shoulder bone. And what is out here, which I'm pointing to at now, is he refers to as the upper arms. So just to make that clear, I'm gonna make a little drawing. So what do we have? Something we can paint with here. All right. So if we have the head here, that is a very beautiful head, then we have a shoulder bone here. And what we also do have, but which we will not address in this particular video, just to give the context here, is we're going to have the upper arms here. So upper arm left and upper arm right here. And what we're going to do in this video here is we're going to create the location of the shoulder here, and the location of the shoulder gets is based on the location of the head. So it's going to take this location here and do something with an offset. And as you can probably guess from the, or see from the drawing here, it's an offset downwards normally. And also we're going to have a rotation part here. I'm just using random colors anyway. So, and this rotation here is also going to affect the location of this shoulder here. So I just wanted to paint that out because it's a little bit easier to visualize and explain that way. So once we now start to get into the code, we can refer back to this drawing here if we need to. All right. So let's go inside the UBIK component here, where we have the skeleton here, or the template, and we created this placeholder function called setShoulder last time, or one of the previous videos. And actually one more thing I want to do before we get started, and it's not something I recommend you to do normally, but just for the clarity of these videos here, I want to append a W here for world, so we can easily tell if this is a world transform or which space it's in. So this is a component transform, but in world space. And these ones I have this comp. I'm just gonna rename them to dot or C. And so the shoulder transform that we're gonna create here is also gonna be a component space transform. So we're going to call this shoulder transform C. And we're going to set that inside this function here. Like so. And it's probably going to need a little bit, quite a bit of space. So we're going to make transform like this. And specifically, it's going to be this location here. And if we refer back to the drawing, some of this is going to come from the head, and it's going to be an offset. And the most logical thing to do is to take Actually, and here you can see I'm taking the head effector in component space. So just be aware that we are going to do these calculations in component space. So let's break that open, and if we just do something very plain as to add a negative offset here to the C part, and then spit that out as shoulder transform. That would be the super simple approach. And if we want to visualize this, let's go into the debug draw here, and then add another draw axis, and let's take this, let's just expand this a little bit. It's because now we have a shoulder transform that we want to draw, but this draw axis here, it's taking a world transform. This is a world transform, so if we just plug it in here, it's not going to work. So we need to convert this back into world space, and we do that by using a compose transform with the reference transform, which is in the component transform in world space. So we're going to move that back into world space using this method here. And let's give it a yellow color, like so, and hit play. Oops. We need to compile something, it seems. I still need to compile something. Let's open this one up. Compile. There we go. Okay, so now you can see we have this the head here, the white ball, this one, and when we move that around, we can see the yellow ball that we just calculated as a negative offset of 25 is being drawn underneath. When we rotate the head, nothing happens. And you could just go ahead and go with this to begin with, to have something very simple to work from. It would be perfectly all right, but at some point you would have to address this this issue, which I'm gonna explain now. And that has to do with the other component here, the rotation part of the head. I'm just gonna see, if you watch my head closely here and you imagine I have a rotation point inside the head here where the pen is. When I move my head down, you can see the location wise, I just moved my head off that point here. So I don't know if you can see that really, but you can see I move my head, I'm just looking down, but it means the location of my head moves. So in order to keep, because what we really want is to have this shoulder, is when I look down, my shoulders didn't move. If I move my head forward or lean forward, it's a different story. But I decided for simplicity to only support this type of movement, so looking down. And on this matter here, I'm actually deviating from the Parche paper. So if you are following his approach, either you decide to follow that, or you can follow my simplified approach to this. So let's continue with that, and you can make up your mind yourself if you want to follow this or not. So if we move this a little bit to the side, because we're going to need a little bit of space for this. So we actually, what actually happens is that if you want to move what we need to do is to move the head, the body, the shoulder that we are creating now, we need to move that backwards in order to compensate for the fact that we're looking down. Move that backwards a little bit and up actually to compensate for that movement, so that the body seems to stay in place more or less. And we can do that in a number of ways, but the most intuitive way I think I can explain this is to kind of imagine you have a point like somewhere around here, which is the pivot point of the neck, sort of. It's kind of hard to see, but here at this point here, sort of where the head rotates from. So one way we could do this is to figure out how do we create that point. So we could take this for now, just to figure out or visualize how. I want to explain how I got to this this approach here. So let's just leave this alone, because I think it's a good idea to keep an offset. Or I decided to do that, so I'm just going to leave that. But let's add something simple to begin with. We know it's going to be back a little bit, and it's going to be down a little bit. So by back, I mean from the looking direction. So if I give it something like 7 centimeters back and 9, I'm just checking my notes here, so 9 centimeters, 9 centimeters down, it would be -9 and -7, like this. So because I just want to visualize this, I'm just going to replace this just for now, so we can see where that puts the location here. So as you can see, it's more or less here, and you can see something is wrong with this, because it's rotated. It was supposed to go back, but it decided to go sideways, and that we can fix quite easily. Well, the head has a different orientation, and we need to. That means that we have to take this direction here and rotate that before we do anything. So and we do not want to take the pitch into consideration at this moment. So I'm gonna do it like this. I'm gonna break this open and then make a new rotator. Make rotator like this, only based on the roll and the yaw. And with this rotator here, I'm going to rotate that direction vector that we just got. Rotate vector here. And I only want the direction vector, so we could, let's make it actually, it's going to be a little bit easier to explain, I think. It's definitely not the fastest or most optimal way of doing it. But let's just type in like something like vector down, and we have a vector forward. And these two vectors we're going to multiply by a float, and this is going to be 7. So notice I'm not typing -7 and I'm not typing -9 because I use actually this should be the backwards vector. Sorry. Back. So this needs to be 9. And then we add these two together, vector plus vector, and then this is what we're going to rotate. Like so. And instead of taking this, which we could see from the previous test was wrong, we're going to take the output of this rotated direction vector and plug it in. So that is going to put it behind a little bit. And if you kind of imagine your eyes will be sort of in the middle of this ball here, then this point here corresponds roughly to that, to a point behind your ears or somewhere here where you would have a rotation point from. But in any way, what you should do at some point is to tweak these values here so it fits with what you want to achieve here. And what you basically want to achieve is a upper body that doesn't move, if you follow my logic here. Okay, so the next part is what we then want with this this point is to rotate it around a pivot point, and that pivot point is actually your head. So if we just take the head effector here, and then we want to rotate this point, let's see, yeah, this point we want to rotate around a vector or a rotator based on the pitch, only the pitch. So that is kind of important. So we're going to create a new rotator down here, and this rotator is only going to contain the pitch component here. And what we then want to do here is to take this this head rotator, this head effector, and then use that as the rotation point, or the pivot point, really. So in order to do that, what we need to do first is to take the pivot point here, move or take the point that we want to rotate and move it into the pivot point space, and we do that by inverting this transform first. And just like when we convert something into component space, we just did that. I believe it was last time here. We did this invert, and then we compose that to get the component space. It's just the same thing that we do it basically here. So we compose like so. And the transform that we want to compose is this one. So don't worry about it. It's going to look a little bit messy to begin with, but we're going to clean it up afterwards. So now we're converting this into the moving into head space. Moving into point into head, or let's call it pivot point, pivot local space. And from here on, we want to rotate it again by that rotator that we just I just mentioned. So we're going to compose again, and you can do this in a number of ways, but in my case, I'm just going to compose this with a another transform. It is very simple. It is based only upon the this rotation. We're not going to touch the location or the scale at all. Just this simple rotation here. So that will rotate it locally around this pivot in the rotate locally in pivot space. I'm not entirely sure. I'm typing the comments here correct, so bear with me for a second. And then the last thing we need to do is just to convert this back again to let's call it original space. Move point back into. So if this is coming from component space, then it will return back into component space by taking this here that we just inverted and connect that up. So this transform that comes out here, I'm just going to make a reroute for now. That is going to be the resulting rotated point. So just to make this a little bit more reusable, we're going to use this in another context later on. I'm going to mark all this stuff up here and then convert that into a function. We're going to call this rotate point around pivot. And let's make it pure, so we can just use it like this. And I think this one also needs to be connected up. So, right. So the shit. This transform here is the point, and I needed to take this, so I just made a little mistake here, so bear with me. This needs to be a transform. This is the pivot. So I need to take this and move down here. So you should end up with something looking a little bit like this. That should be correct. I would call this something like transform, and this called delta. Okay, so this is the point that we actually want to rotate around component like so, and so just to finish this up, because now we are almost done, I believe. We're going to take the 25 fixed 25 units negative in the C direction. I'm going to take that and still add into the location here. So we want to break this out, and like so, break this out, and then add in the 25 centimeters here. That should be, so instead of going from here, you wanna, let's just split it up here, put it in like here. So this, I believe, unless I made a mistake, should be the end result of how we place the shoulder location. Let's see. Okay, anyway, let's just test it out. So it does actually look wrong, or what? No, it actually does look correct. It probably needs some tweaking. I don't know. This is okay, I believe, and it moves correctly. Yeah. So it might be a little bit too far down, I don't know. But anyway, just for now, just use these values here and make sure that you implemented this rotate point around pivot, because we're going to use that in a later context here. And as I mentioned, these values here, we probably need to tweak them at some point. Yeah, for now, I hope you can use this, and we will continue in the next. I think with we will start looking at how we can do the rotation of the shoulder bone, but I have to break this up, because we also need to create something we can use to visualize and start testing in virtual reality. So we need to create a little mirror material also, before we get too much further into the videos. Anyway, thank you. I hope you got something out of this, and I will be seeing you in the next. Bye.